Hi guys, last class we discussed about Kirchhoff laws. Kirchhoff laws are very helpful if the circuit contains more complex combination of resistors and cells. If the circuit cannot dissolve like series and parallel combination, so by the time we need to apply Kirchhoff rules to find out the current or potential difference across the given component. So Kirchhoff rules contains two rules. One is junction rule. The junction rule says that at a given junction, the algebraic sum of currents entering towards the junction is equal to the algebraic sum of the currents leaving the junction. So how much or how many currents which are entering towards the junction? So those many supposed to leave the junction. So the algebraic sum, the total sum of currents entering towards the junction is equal to currents leaving the junction. So when we are applying junction rule, keep in mind that if the network contains similar type junctions, so here we can see the branch B and E. So here B is one junction and E is another junction. So at B, I1 current is entering and I2 is leaving and I3 also leaving. And same currents also following same pattern at E also. In this case, no need to consider two junctions, because if you consider two junctions, we get the same result. So one junction is enough and more to solve the component values. Second rule is that loop rule. The loop rule says that the algebraic sum of the potential differences around a closed loop must be zero. So in a given network, the algebraic sum of the potential difference. So here E is the potential difference or EMF across the cell, and delta VCD is the potential difference across this resistance. So to find out the potential difference across this resistance, we need to calculate current through the resistance. And if you multiply current with resistance, we get the potential difference across the resistor. But the algebraic sum, the total sum in the given network, that equal to 0. So this is that Kirchhoff loop rule or voltage rule. So while we are applying loops, so be careful that don't consider the loop which already we considered. So in the fourth figure, if you can notice, the loop A, B, E, F, A and E, B, C, D, E, which already covered the components in the given network. So if you are considering one more loop which is combining entire the network, so that kind of action is not necessary, because when we write more incorrect equations, so we will be stuck up while solving those equations. To apply these rules, we need to follow certain sign conventions. So these are the sign conventions. When we traveling in the loop, so our direction of travel and current direction across the resistance, if they both are same, both are in the same direction, so that the direction of travel and current direction across the resistance, if both are same, we need to consider that product value as negative minus IR. And similarly, if it is opposite, if my direction of traveling across the resistance and current direction through the resistor is opposite, we need to consider that as positive plus IR. Similarly for cell, if I am crossing cell from negative to positive, so by the case we need to consider that as positive EMF plus V. For it is opposite when I am crossing cell from positive to negative. So by the case, we need to consider the EMF value as negative. So these four rules we need to apply while solving Kirchhoff rules, while applying Kirchhoff rules for a given network. So using Kirchhoff rules, we need to find the variables which are asked to find, like current, resistance and potential difference across the resistors. We need to find out. For that, we need to depend on as many as loops, independent equations. So those equations we will write after considering proper loops, and all the loops we need to apply these two rules. One is junction rule and one is loop rule. Finally, I can say that the junction rule is the consequence of conservation of charge and the loop rule is consequence of conservation of energy. Let's try to apply these rules to one of the given network so that we can solve from the network maybe current or the potential difference. So here given that one network is given, using Kirchhoff laws, calculate the potential difference across 8 ohm resistor. So in the given network, so this is the 8 ohm resistance. Across 8 ohm resistance, we need to calculate the potential difference. So if you remember, potential difference equal to the product of potential difference V equal to the product of voltage and currents. Current and resistance. So here I already know the resistance value, that is 8 ohm, or I need to find out that what is the current which is flowing through the 8 ohm resistance. So first we need to find what is the current which is flowing through the 8 ohm resistance. So here two cells are given. Suppose if I consider this is cell 1, so let me take this is the amount of current I1 which is passing. So this is a junction at D. The same current I1 is also entering towards the junction. So that is I1. Similarly, if you can see from the FE branch, from FE side, so this is, if I consider I2 current, so the I2 current is also flowing through along this I2. The same current I2 also flowing through the junction D. Now the total current which is flowing through the junction, that equal to I1 plus I2. So while we write the expression for the current, we need to consider like this. So let me take this as small font so it can be visible. So the current through this resistance, that equal to I1 plus I2. Now the same current also will be flow across this, and when it comes to at here, now the currents will divide again. The I1 current will be flow in this direction, and this is I2 current, and same I1 current is also flows in this direction. So this looks like some messy. I would like to draw each loop separately since we need to apply the loop rule. So let me draw loop A, D, C, B, A. If I draw the loop separately, so this is cell, and after that, so here I am having 8 ohm resistance, and after that here 6 ohm resistors. This is 2 ohm resistance. So this is A, B, C, D. 4 volt. The current is I1 across this arm, but when it comes to at here in this arm, current equal to I1 plus I2. So this is 8 ohm. So the same current flows at here, but when it comes to here, again current gets divided. So this I1 current will be flows. So this is 6 ohm, and same current also will be flow I1 in this direction, and this is 2 ohm. Now we need to apply loop rules. So for that, just try to remember the loop rule. So here I am having the loop rules. Suppose if I am traveling in the loop from the A, B, C, D, A, I am traveling within the loop along this direction. I am traveling inside, but inside looks messy to draw, so that's why I draw outside. There's nothing big deal. Now if I am traveling along in the direction, so it means I am traveling in the clockwise direction. So when I cross the cell from positive to negative, so my direction of travel from the positive to negative. So in that case, I need to consider that potential difference value as negative. So here first I will get -4. Then after, if my direction of traveling and current in the 2 ohm resistance across at here. So my direction and current direction, it's both are opposite. So for resistance, if my direction traveling and current direction is both are opposite, we need to consider that as positive. So at here, it's a positive 2 ohm, the current across that is I1. And when it comes to BC arm, so current direction and my direction of traveling. So again here it is opposite. So if it is opposite, we need to consider that as positive. I can get 6 I1. And when it comes to 8 ohm resistance, so my direction of traveling and current direction. So again at here they both are opposite. If they both are opposite, again we need to consider that as positive. So at here I can get that 8 of I1 plus I2. So if I write this equation properly, so 8 of I1 plus I2 plus, if you can combine these two, I1 of 2 plus 6 is equal to 4. I said that it's supposed to write equal to 0. So if you can write equal to 0, then this expression will be changes like this. Or further also you can simplify this one. So 8I1 plus 8I2 plus again 8I1 which is equal to 4. So I can get that 16I1 plus 8I2 equal to 4. Let me take as equation 1. So this is equation I got it from the loop A D C B A. Now let me consider another loop. So here you can solve furthermore. If we can cut with the 4, I divide with the 4 entirely for simplification. So this equation will reduce it further as 4 times 4I1 plus 2I2 equal to 1. So let me take this as equation 1, which is easy to solve. Now let me consider another loop. So from the loop D, C, E, F, D. So in this loop, if I am traveling in the loop along in this direction, clockwise direction, Now we need to write the expression from loop D, C, E, F, D. Now first I would like to start at 8 ohm resistance. So in the 8 ohm resistance, my direction of traveling and current direction, they both are the same. So I am traveling in the loop and current in the across the 8 ohm resistance, they both are in the same direction. So we need to consider that as minus. So I can get that as negative minus 8 of I1 plus I2. Now if I comes to across the CF, across the 1 ohm resistance, so 1 ohm resistance, the current is flowing in this direction. I am also flowing in the same direction. So again in this case, current direction and direction of travel, they both are same. So again at here I need to consider that as negative, but in this arm current is divided, current I2 only flowing, so we can write that I2 times 1. Now finally at cell, I am crossing cell from negative to positive. So if we cross cell from negative to positive, so we need to take that as 6, a positive value. So positive 6 itself only. And across final resistance 4 ohm resistance. So if I finish the loop like this, so current direction and direction of travel, here also again the same direction. So if again the same direction, so we need to take that as negative. So finally I will end up by writing here minus 4I2, which equal to 0. So if I rewrite the expression, it looks like very big, but we will simplify this equation. First I will multiply this minus 8I1 and minus 8I2, again minus I2 plus 6 minus 4I2, which equal to 0. So first let me add all these I2s, because I2s are more. So here minus I2 and minus I2, here it is minus 9I2, minus 9, again minus 4. So I think I will get minus 13. So minus 8I1 and minus 13I2 plus 6 equal to 0. Now we will rearrange these equations and we can write that. So I can write that 8I1 plus 13I2, which equal to 6. So you can take that as equation 2. Now here our task is to solve these two equations. So if we solve these two equations, now how can I solve? First I'll multiply equation 1 with 4 and then I will subtract from 2. So if I multiply equation 1 with the number 4, so that equation will be changes as, again it will be turns, it's supposed to be multiplied with 2, then it's easy to cancel with 2I1. So I am multiplying equation 1 with 2 and subtracting from second equation. So here round up are the equation numbers, and which is not round, so that is a number. So I am multiplying equation 1 with 2, so it is becomes that 8I1 plus 4I2, which equal to 2. And let us subtract with this second equation 8I1 plus 13I2, which equal to 6. subtract this. So here I can take negative sign, so here also negative and here also negative. I hope you are familiar with this type of notation. So these two gets cancelled. Now here I can get that 4i2 minus 13i2 is equal to 2 minus 6. So here I can get that minus 9i2 equal to minus 4. So minus gets cancelled. So i2 equal to 4 upon 9. So this is the expression what I got it for i2. Substitute i2 in any one of the equation. I would like to put i2 in equation 1. So equation 1 is 4i1 plus 2i2. So 4i1 plus 2i2 is equal to 1. So in the place of i2, if I can take that number at here, having 4 upon 9, therefore 4i1 plus 8 upon 9 equal to 1. So let's solve this. 4i1 equal to 1 minus 8 upon 9. So 4i1 equal to, take the LCM, 9 minus 8 upon 9, again it's a 1 upon 9. So that implies i1 equal to 1 upon 9 times 4. So 1 upon 36. This is amperes, since we are writing amperes. Now I got it, i1 equal to 1 upon 36 ampere and i2 which equal to 4 by 9 ampere. So but if you can see the circuit through the resistance, 8 ohm resistance, the total current is passing through 8 ohm resistance is the sum of i1 plus i2. So i1 plus i2 is the amount of the current which is passing through 8 ohm resistance. So add that two currents. So the total current i1 plus i2 equal to 1 upon 36 plus 4 upon 9. So if you can take this LCM and you can solve this, I can end up with 17 by 36 amperes. So this is the total amount of current which is passing through the resistance of 8 ohm amperes. i1 plus i2 equal to 17 by 36. So here I am not simplifying further because I will get fraction at there. So finally I need to calculate the potential difference across 8 ohm resistor. So potential difference V equal to IR. So I got the current at here, current equal to 17 upon 36 and resistance here itself 8 ohm. So we can solve this. So this is the 8 ohm resistance. They were asking what is the potential difference across that. Now simplify this. So we can get that 4 2s are 8 and this is 18 2s are 36. Further simplify, we can finally end up that here's the V equal to 4.25 volts. So the potential difference across the 8 ohm resistance equal to 4.25 volt. So this is how we need to apply Kirchhoff laws, and we need to find the corresponding current values at there, and after that we need to find what the value which is asked in the question. Here it is a potential difference. We can use the corresponding formula to find the end result.